Greetings. In the previous lectures, part 1 and part 2, we have started with methods of curve tracing, and we have started with the first type of curve, that is Cartesian curve. We have studied the four rules of symmetry, then points of intersection, third asymptote, and the fourth one, spatial points. In this lecture, we will be looking at the last rule number 5 and some important remarks to trace the curve of Cartesian form, and we will solve two examples on curve tracing of Cartesian curves. So rule number 5 is region of absence of the curve. First of all, if possible, try to express the equation explicitly in the form y equal to f of x, or we can express it in the form x equal to f of y also, if possible. For y equal to f of x, if y becomes imaginary for some value of x greater than a, I am saying this is assuming for some value of x greater than a, y becomes imaginary, then no part of the curve lies or exists beyond x equal to a. Similarly, if for y equal to f of x, for some value of y less than b, again a correction. Suppose here we consider x equal to f of y. X equal to f of y. If x becomes imaginary for some value of y greater than b, then no curve exists beyond y equal to f of y equal to b. So basically, what we have to do, we have to explicitly express y or x in one of the variable, and then we have to check for the values of x or y where function becomes imaginary. So at that part, the curve does not exist. So let us see some remarks, important remarks while drawing the instruction, we can say drawing the curve trace of first type, that is Cartesian form. First, to solve y equal to f of x, put x equal to 0 and observe y. Then also observe how y varies as x increases from 0 to infinity. Also observe how, for which values y equal to 0 or y equal to infinity. So if you consider the first one, E part, to solve y equal to f of x, we will put x equal to 0 and we will observe y. Also we will observe how y varies as x increases from 0 to infinity. Also observe the values of for which y equal to 0 or y tends to infinity. This will actually give you the nature of curve. So if y tends to infinity as x tends to a, then x equal to a is an asymptote parallel to y-axis. If x tends to infinity as y tends to b, then y equal to b is an asymptote parallel to x-axis. If y tends to infinity as x tends to infinity, there may be an oblique asymptote. If the curve is symmetric about x-axis, then, or in the opposite quadrant, then only positive value of y may be considered. We may draw the curve for negative values of y by symmetry. If necessary, change the equation into polar form. Sometimes it may happen that the curve is given in terms of x and y, that is Cartesian coordinates, but to trace that curve is difficult than polar form. So try to express these to polar form, or we can say parametric form also. If possible, prepare a table for certain values of x, y, dy by dx, which help us to draw a rough shape of the curve. Student, be sure that whatever the curve you are drawing, it need not to be perfect. it should be a rough curve. You can guess according to the values and these remarks how the nature of curve is there, and you just have to draw the curve nature. And obviously the sketch should be rough. So let's solve some examples based on curve tracing of Cartesian form. First example, trace the curve y square into a minus x equal to x cube. So if you observe, first we have to start with symmetry. Second, we have to check the point of intersection, that is whether the curve is passing through origin or not. Third, asymptote. Fourth one, special point. And the fifth one, region of abscess. And using this all, we will draw the rough sketch of the curve. So first, if you observe the degree of y, there's only one term in y, and it is even. But if you observe the degrees of x, they are not even throughout. Therefore, this curve has even powers of y only. Therefore, it is symmetric about x-axis. As we have seen in the symmetry, then it is symmetric about x-axis. Second property, if you put, we can consider y square equal to x cube upon a minus x. So if you put x equal to 0, you will easily observe that y equal to 0. Therefore, curve passes through origin. Now we will be interested in finding the tangent at origin. So whenever we want to find the tangent, we will consider the least highest degree term of y. So if you compare this, we get y square into a minus x equal to x cube. Therefore, y square a minus y square x equal to x cube. Comparing the least degree term to 0. Therefore, y square a equal to 0, and that will give you y equal to 0. So we will be taking least degree term in y throughout, in whether it may be in x or it may be in y. We will be taking least degree term. So here the least degree term is y square a, because all the other terms having degree 3. Therefore, y square equal to 0, that implies y equal to 0. Therefore, y equal to 0 is the equation of x-axis, hence the tangent is x-axis. Therefore, equation of tangent at origin is y equal to 0, that is x-axis. Now third, we will consider the asymptote. So as if you consider y square equal to x cube upon a minus x. So if you consider x tends to a, y is tending to infinity. So as we have seen in the remark part B, for x tends to a, y tends to infinity, then x equal to a must be an asymptote. This is one way, or you can find this comparing highest degree of y equal to 0. So here highest degree of y is y square, उसका coefficient है a minus x, so a minus x equal to 0, therefore x equal to a is the asymptote parallel to x-axis. So x equal to a is the asymptote, we can say. Make a correction, x equal to a is the asymptote parallel to y-axis, not x-axis. It should be y-axis. So now we will be interested in finding whether is there any special point. Special point means, is there any double point? So if you look at the equation, the origin is double point, because y square equal to 0, that is y has two values 0, 0, x cube equal to 0, therefore it has 0, 0, 0, 3 values. Obviously 0, 0 is the double point. And if you consider the previous part, tangent we are getting only one at origin, that is x-axis. So origin is a double point where the tangents are real and coincident. Therefore 0, 0 is a cusp. So at 0, 0 you will draw the nature of cusp point. So that will give the first we can say point where you can have the nature of the curve. Last one is a region of abscess. Now as y square equal to x cube upon a minus x, therefore y equal to square root of x cube upon a minus x. Now if you observe, for x negative, minus cube will be minus. So square root of that minus number does not exist. Hence, for x less than 0, y is imaginary. Hence, no part of curve lies to the left of x equal to 0. Similarly, if you put x greater than a, then a minus x is negative. Hence, y is square root of negative number, that is, y becomes imaginary. Therefore, no part of curve lies to the right of x equal to a. So, this is the description of the curve. Let us see what is the rough sketch. So, this is the rough sketch of the curve. Now, if you look at, as I said, we get 0, 0, curve passes through 0, 0. Curve is at 0, 0, curve having cusp. So, this is cusp. Then x equal to a is asymptote. This is the vertical asymptote. There is no curve lying above x equal to a and left hand side to the x equal to 0. So this is the rough sketch. So quickly we will see the next example. Trace y square to x square minus 1 into x equal to x. So clearly as degree of y is even, x का degree हर जगह even नहीं है, therefore it is symmetric about x axis. Whether it is passing through origin, if you put x equal to 0, y becomes 0, therefore 0, 0 satisfies the curve. Therefore curve passes through origin. So we are interested in finding the tangent. So y square into x square minus 1 equal to x, therefore y square, x square minus y square equal to x. So comparing least degree term to 0, so x equal to 0, that is y axis. So equation of tangent is x equal to 0, that is y axis. The asymptote, again y square into x square minus 1 equal to x, comparing the highest degree term equal to 0, and that is x square minus 1, therefore x equal to plus or minus 1. Hence asymptote is parallel to y axis. So x equal to 1 and x equal to minus 1 are two asymptotes. Special points, as if you observe 0, 0 is the one point, it is not a double point, because in the previous curve, here if you put x equal to 0, then y, though y square equal to 0, but x has only one value, 0. Therefore 0, 0 is not a double point. So curve contains no special point. A region of absence, if you consider y equal to root of x upon x square minus 1, obviously for x negative, rather in 0 less than x less than 1, y becomes imaginary, because x square minus 1 is negative. Hence there is no part of curve lies between 0 to 1. Similarly, if x less than minus 1, then the curve is imaginary. Therefore, no part of the curve lies to the left of x equal to minus 1. So if you consider the rough sketch is like this. Now why we have if you consider 0, 0 is not a special point. So why this nature is there? Because you can simply put the values between 0 to minus 1 and just simply place the values and just join them by a curve. We'll get this nature. This is the nature of the curve. So this x equal to 1 is the asymptote, another x equal to minus 1 is the asymptote. So as I said, the sketch has only 2 marks. The description is important, and if you try to describe the curve, you'll be easily able to understand how we can draw the curves. So I have given 2 different examples other than notes. There are 3 examples solved in the notes. Look at these examples, revise, and try to draw or try to trace the curves of first type, that is Cartesian curve. In exam, you have to attempt at least one example on Cartesian curve. So try to solve the examples and look at the solved examples also. They are given in the book also. I have given some additional examples in note. and some additional exam in this video. Thank you.